Going on to page 20, we're going to look at what is called piecewise linear functions. And what this refers to is that we're going to take a piece of this, as we see here, and then a piece of this. And also there are these restrictions as we gather material to plot into our graph. So let's look at strategy to get us started here. I would suggest the first thing you do is put your equation up here. X minus 1. I'm using a very thin pen so we can work this graph a little better. And then the other one is just 2. And remember, we can substitute a y for this. So in a sense, this is y equals this, and this is y equals that. Now we're going to set up a t-chart. And for this equation, we say x is less than or equal to 3. So what values can you have here? Well, 3 is definitely included. And since it's less than 3, we're going to go 2, 1, 0. And this would be enough to give us our plot. And for this one, if you note what this equation is, this is an equation of a horizontal line. So y is always going to be 2. But here they're saying x is greater than 3. So what we do is we put a 3 here, but we put a, let me do it in blue, a kind of a dotted circle around that 3 to indicate that's not in the set, but we anchor it to that spot. And then greater, we're going to use a 4, a 5, and a 6. So let's do this one and fill in these points. So we have here x is 3. 3 minus 1 is 2. 2 minus 1 is 1. 1 minus 1 is 0. And if x is 0, minus 1. So now we're going to put this into our graph. We'll graph this line first. So 3, 2 is included in the set. So 1, 2, 3, 2. So this is our first point right there. 2, 1. 2, 1 right there. And 1, 0. 1, 0 is right there. So we actually have enough points. We could plot this other one, but it's not needed. We're now going to take our line, and from here it goes like so. So there's this line. So now we're going to plot this information here. Now 3 is not included in the set, so we're going to go 3, 2. So 1, 2, 3, 2. So in a sense, there's like a hollow right there for the first member of this line. And then we go 4, 2, and we make a line then this way. And we can darken that a little bit here. There we go. So there is our first example. Now notice, is this a function? Well, if we do the vertical line test that we mentioned and bring this very thin vertical line over the diagram, over the graph, does it intersect in more than one place? And you might say, well, how about here? No, because it's a hollow there. So the answer is yes, this is a function. Alright, so hopefully you've taken some notes. This is the data, and this is what we said were piecewise, where you have a piece of something and then a piece of something else, and you put it on the same graph. Now, when I set these up, I like to follow a protocol. So we said we could replace this with a y. So here, y will equal, and I'll put it in slope-intercept form, negative x, negative 1. All right. And our restriction here is, start our little t-chart here. It says x is less than or equal to 2. So we're going to have a 2, a 1, a 0, and a negative 1. But this gives us enough to plot it. Now for our second graph, it's going to be y equals 2x. I'm just rewriting it in slope-intercept form, minus 4. And our restriction for this is x is greater than 2. So we'll put some values here. 2, but remember now, 2 is not included in the set. So we'll put like a little red circle around there to indicate that's not in the set, but it sort of hinges or hooks to our graph at that point. And then since it's greater, it will be 3, 4, 5. Now let's get some points. So here, if an x is a 2, a negative 2 now, and a negative 1 is a negative 3. X is a 1. A negative 1 and a negative 1 is a negative 2. If x is 0, there's our y-intercept, a negative 1. And if x is a negative 1, a negative of a negative 1, it makes it a positive 1, this one will be 0. So again, enough points to get a line. And then here, 2 times 2 is 4, minus 4 is 0. 2 times 3 is 6, minus 4 is 2. 2 times 4 is 8, minus 4 is 4. 2 times 5 is 10, minus 4 is 6. So now we're going to take the pieces of our function here, piecewise, and plot it on our graph. So x is 2, negative 3. So x is 2, negative 3. 1, 2, 3. A solid dot right there. A 1, a negative 2. A 1, a negative 2. A 0, a negative 1. A 0, a negative 1 right there. And then negative 1, 0. So we have our line here. And it will look like that. And keep in mind it goes on to infinity in that direction. Now for this one, and I'll change color for this, here we have a 2, 0. So 2, 0, we're going to put a little circle there. That's where we hook up our line, but the 2's not included. And then we go 3, 2, so there's 3, up there. 4, 4. So 4, 1, 2, 3, 4. And then 5, we go up 6. So again, our line for this will go like so. Whoop, let's get it a little better. There we go. And again, this goes on to infinity in that direction. So once again, we ask, is this a function? And does it pass the vertical line test? Well, as we bring the vertical line over our diagram, it gets to this point, but remember that 2 there is not included, but here it is. So again, when it gets to this point, it only intersects in one place. So this is a function. This is a piecewise graph, where it's a piece of one thing with its restrictions, and a piece of something else with its restrictions. Let's go on. And to save time, I've set it up here. Now let's look at our restrictions. For this first equation, x is less than or equal to 2. So 2 is included, and then 1, 0, negative 1. Again, we don't need that many points, but it's good to have for sure. Now here, x is greater than 2. So this will be a 2 here, but 2 is not included in the set. So we put that little circle around it to indicate that 2 is not included. And since it's greater, we're going to go now with 3, 4, 5. All right, let's give you a moment to fill in some points. Okay, we have some points. Now we want to plot. So again, we're doing this piece of a piecewise linear function. So 2, negative 5. So let's go 2, negative 5. 1, 2, 3, 4, 5. And that's in the set. Then we go 1, negative 4. And then 0, negative 3. Negative 1, negative 2. And our line then for this one is like so. Now, in doing the next one, we have 2, negative 3. So 1, 2, 1, 2, 3. We put a circle there, and then 3, 0. 1, 2, 3, 0 right there. And then 4, 3, 1, 2, 3. And then 5, 6. So this line then looks like so. I'm off just a little. But anyway, close enough. Is this a function? Again, does it pass the vertical line test? All of this is yes. It gets here and it intersects this point, but this is hollow. This is just where we link up our second piece. So this passes and is a function. All right. So again, to save time, I've set it up. What's our restriction here? Well, x is less than or equal to 1. So we're going to start with a 1. That's in the set. And less than that is 0. And then a negative 1, negative 2, negative 3. Again, we may not need that many points. And then here, x is greater than 1. So 1 is the hookup point, so to speak. And we're going to put a circle around that to indicate that's not in the set. And then 2, 3, 4, 5. Now this is a little tricky because it's absolute value. So let's see what we get. So if x is 1, the absolute value of 1 is 1. 4 times 1 is 4. If x is 0, the absolute value of 0 is 0. 4 times 0 is 0. Now if x is a negative 1, it comes out of there as a positive 1. 4 times 1 is 4. If x is a negative 2, it comes out of there as a positive 2. 4 times 2 is 8. And negative 3 comes out as a 3. 4 times 3 is 12. So we're off our graph here anyway. So let's do this one. 4 times 1 is 4. 4 times 2 is 8. 4 times 3 is 12. And we're off the graph. So let's plot it now. A 1, 4. 1, 1, 2, 3, 4. Right there. 0, 0 is right there. A negative 1, 4. Negative 1, 4 is right there. A negative 2, 8. So negative 2, this is 7. 8 is right about there. All right, we have enough. So now to sketch this in, it's going to go like so, and then like so. So that's this piece of it. Now this piece, as we plot in those points, and I'll change color, a 1, 4. So 1, 1, 2, 3, 4. So we're going to hook that up with a circle. 4 is not in the set, but it sort of hooks there. And then we get 2. I think did I say an 8 here? I thought I said an 8. I didn't put an 8 though. 2 is 8. So over 2, up 8 is right there. So this graph then looks like so. All right, so we're sort of getting a V. The question is this a function? Yes, this is a function. It passes the vertical line test. Now, when we often have, and I don't know if we worked on these before, but the absolute value of something, usually it's some sort of V-shaped thing like this. But because of our restriction here, it only went up to there. It didn't make a nice V. If we didn't have that restriction, it would have looked just like that. Okay. Now in setting this up, again, it's very similar to the one we just did. The key is, what are our restrictions? Because that helps us determine what we're going to put in our t-chart. So here they're saying values of x are less than or equal to 0. So this will be 0, negative 1, negative 2, negative 3. Just enough to get a line, or a little bit more. And then here, x is greater than 0. So we're going to use a 0, 1, 2, 3. But keep in mind now that this 0 is just our anchoring 0. It's not in the set because of that inequality sign. So let's plot this one. Well, let's get some points here first. If x is 0, this will be 0. If x is a negative 1, comes out as a positive 1, this is 3, this is 6, this is 9. So any value of x comes out as its positive value, and we just multiply. Now here, whatever y is, that's what x is. So this is going to be 0. This is going to be 1, 2, 3. So now we graph it. 0, 0 for this first one right there. Negative 1, 3, 1, 2, 3, negative 2, 6, negative 3, 9 is up there somewhere, and this is our line. Now notice that when it was 4, the line was a little closer to the y-axis. That it's 3, it spreads out a little bit more. This is something we'll use later in the course too. And then now this one, and we'll change colors. 0, 0. Now don't forget we're just anchoring at that. So we put a circle there for this point. And then it's going to be 1, 2, 3. So this one looks like this. So it's not quite the V shape that we had because of this value is a little different. Okay, well let's wrap this up, and it's 21 minutes, so we're just going to have this lesson on this video.